Good afternoon, ladies and gentlemen. My name is Giulio Caperdoni, and I am a glass explorer. What I want to do is to tell you about Google Glass for LIS project developed by Rokivo Inc. and VDM Consulting in collaboration with Egyptian Museum in Turin. The museum enthusiastically embraced this project. Who we are? We are two different companies, and the mix is user experience and technology. And the rock hand sign reminds the Steve Jobs famous Beatles quote. He said, "My model for business is the Beatles. They balanced each other, and the total is greater than the sum of parts." And this is true for us, for Rokivo and VDM. Rokivo is an American company. It's based in New York and Turin. It's specialized in the user experience or the design of experience on different types of screens: computer, smartphone, tablet, glasses. And Rokivo hashtag is We Rock. VDM Consulting is an Italian company. It's based in Milano. It's a key player in the digital context and focused on technology innovation for web, mobile, and wearables. And of course, VDM hashtag is We Roll. So let's rock and roll and start with the presentation. Rokivo and VDM have brought to Italy one of the first prototypes almost 1 year ago of the Google Glass Explorer edition. I am Giulio Caperdoni, as I already told you. I'm the innovation driver in VDM Consulting. I'm the only one speaker today because Valerio Saffirio, who was supposed to join us, is not able for a last-minute urgency, and so I am the only one. What does it mean to develop for Google Glass? Google introduced Glass with a bang, even if the company has not advertised this technology to the general public. Glass are much more popular than advertised products. Wearables, smart watches, tablets, smartphones. From our point of view, each project developed for the Google Glass is an ongoing challenge. It is not only about using mobile and wearable technology, but also, and above all, about dealing with a continually evolving device that's not yet in a stabilized shape. There are two options to develop on Glass: Mirror API and GDK. Timothy Jordan, a Google Glass developer evangelist, gave developers a sneak peek at South by Southwest in Austin in March 2013 of Mirror API. And in November of the same year, Google revealed in San Francisco at a Glass hackathon the GDK. An hackathon is an hacker marathon, usually one-day hands-on event where software developers, interface designers, project managers collaborate intensively on software projects. The Mirror API allows you to build web-based services called Glassware that interact with Google Glasses, but do not run on it. And there is also, let's say, a man in the middle, the Google Cloud. So there is your app running on your server. There is the Glass where you see the layout of your app, and in the middle there is the Google Cloud. The Glass Development Kit is an add-on to the Android SDK that lets you build glassware that runs directly on glass. So, for example, you can create app that can run offline. It was not possible with Mirror API. You can directly access to the glass hardware. You can have a real-time user interaction using GDK. The focus on GDK is an Android SDK add-on that contains glass-specific features. What's the difference between API and SDK? An API is an interface into a system. For example, in your house, a system is the AC wiring, and the API is the socket in the wall, is an interface to that system. So you can go to a store, buy an electronic device, and easily plug in and interface it to the system. An SDK is an implementation tool. For example, if you would like to build your own socket and plug with, for example, 10 pins. So with the glass GDK, you can build your own app, adding additional functionalities to the functionality already available on glasses. You can add previously non-existing voice controls or previously non-existing gestures to glass app. And you can integrate your app with external services. For example, you could integrate your app with an indoor positioning system, as we're going to see later on, or you can integrate your app with a CRM profiling your registered and recurrent visitors. Designing for glass has its own rules and guidelines that are different from the existing mobile and desktop platform. While computers and smartphones may store a medium to large quantity of data, glass works best with information that is simple, relevant, and current. Glass is let's say, a for now device. The smartphone is a device for data of the last month, a laptop, a device for the data, let's say, of the last year, and the cloud is for forever, for your most important data. But the glass is a for now device. The user interface elements of glasses allow three pattern types. Static card, displaying text, images, video. Live card, showing content that can constantly be updated. And immersion. Immersion is a different way of dealing with glass. You can build your own app with its specific user experience. When Neal gave his presentation, he was using cards. Each of his slides was a card, a static one. Google Glass for LIS. What the LIS language is? The LIS language is the Italian sign language used by those deaf people that cannot speak or write Italian. Sign language is completely different, a completely different language to Italian with its own grammar, syntax and stylistic nuances. Every community may have its own sign language. The Italian sign language is different from the one used in America. The American sign language is different from the sign language used in the UK, and even in Italy, there are differences between sign language used in northern Italy and sign language used in southern Italy. Signs are the combination of many parameters. Manual parameters, for example, hand movements, hand orientation, place, the hand in front of the mouth, the hand in front of the stomach, the hand in a neutral place, and configuration, open hand, closed hand, folded fingers, and non-manual parameters, facial expression, oral behavior, and posture of your body. Each sign has been obtained as a combination of basic unit of meaning called kerims. A kerim is functionally equivalent to the phoneme of oral language. For example, mom's car in sign language is the combination of 3 different signs: mom plus car plus hers. Google Glass for LIS is the first experimental project to develop an app intended to provide a full and accessible museum experience to deaf people. It's a project by Rokivo and VDM Consulting in collaboration with Egyptian Museum, 2 different universities in Torino, Politecnico di Torino and Università degli Studi di Torino, and the National Deaf Representative Organization, and is sponsored by Torino Municipality. Please start the video. The video, please.
La piattaforma tecnologica sviluppata nell'ambito del progetto Atlas permette la traduzione da italiano a LIS, la lingua dei segni italiana, e la visualizzazione tramite attore virtuale. Riteniamo che questa piattaforma possa essere utilizzata anche in ambito museale, consentendo la migliore accessibilità.
Thank you. This video is available on YouTube, both in the Italian and in the English version. So let's go back to the PowerPoint slides, please. How does it work? Within the museum, the deaf person wears Google Glass and looks at the statue of interest. Google Glass for LIS app recognizes the statue based on its position. The information on the statue are linked with the corresponding translation produced by the Atlas platform and rendered through an avatar signing the LIS. And Google Glass displays the avatar on its display. This is the final user experience from the point of view of a deaf person wearing glasses, where the avatar is in the top right corner of the right eye. So it does not interfere with his view. The Atlas platform. Atlas stands for Automatic Translation into Sign Languages. It's a huge project started in 2009, funded by Regione Piemonte and the EU. And the platform is able to translate any Italian text or audio to LIS, creating in real time an avatar that can be displayed on any digital device. The platform is a set of converter tools, but is also a set of vocabulary. At the moment, there are, for example, the weather forecast vocabulary, the train station vocabulary, and we are going to add the museum vocabulary. For example, we added the needed sign for the Ramesse, the second statue of the proof of concept video. The Google Glass for LIS app is a sort of, let's say, last mile for the Atlas platform. The last mile in technology communication is the part that actually reaches the final customer. Google Glass for LIS is the last mile for the Atlas platform, meaning that is the part that actually reaches the glass users. Sorry for the Italian of this second video. It's a short video, a few seconds, but it's meant just to give a hint on a real-time translation capability of Atlas. This is a TV weather forecast demo. Please start the video.
Locali addensamenti potranno interessare il settore nord-orientale, poi a partire dalla serata un aumento della nuvolosità su quello occidentale. Ancora correnti settentrionali, molto mosso lo Ionio, generalmente mossi gli altri mari.
Thank you. Let's go back to the slide. Evolutions. Not all the deaf people use sign language, but there are some deaf people that are used to closed captioning. That's why the final version of the application configuration settings will let the user to opt for LIS or subtitles. And the second evolution we are working on is making the entire museum interactive with indoor positioning systems. And I would like to close my presentation focusing on indoor positioning systems. We spend most of our time indoors, working, eating, shopping, at the mall, at the office, at museums. Think back when GPS and web maps first emerged. No one knew what to do with it beyond some trivial apps. Today, location and maps are built into hundreds of apps and millions of websites. The same will happen in the future with indoor positioning, bringing the power of GPS and maps indoor and tying digital information to physical places. For example, instead of punching a 3-digit number into a handheld tour guide, you could walk up to a painting, pull out your smartphone, and find additional info right there waiting for you. For the moment, no single technology is ubiquitous. There are trade-offs to each of the technologies. Wi-Fi is low cost and ubiquitous, but is not very accurate. High accuracy is considered 1 to 5 meters, medium accuracy 6 to 10 meters, higher precision location technology user require higher costs and infrastructure work. Currently, we're working on 2 different indoor positioning technology. The first one is Wi-Fi fingerprinting, and is based on measuring the intensity of the received Wi-Fi signal and generating a sort of fingerprint for every different position. The glass compares its current Wi-Fi fingerprint to a fingerprint location database in order to find its position, and the accuracy depends on the number of positions that have been previously entered in the database, but the accuracy is going to be between 5 to 10 meters using this technology. There is a glass issue. Wi-Fi signal sampling frequency is much slower than usual, than on smartphones, in order to safeguard battery life of glasses. So localization takes longer than with a smartphone. Beacons. We are in 2014, and one of the most exciting things going on in consumer technology is Bluetooth. But this isn't the maddening battery leaching, why won't it stay paired old technology. Is a new standard, Bluetooth version 4 or Bluetooth low energy, which solves many of the technology's perennial problems with a new protocol for ambient, continuous, low power connectivity. Beacons are low-cost gizmos that continually beam out a Bluetooth signal. They could run up for a year or 2 years on a small watch battery and come in different formats, including small coin cell power devices, USB sticks, and also softer versions running on iPads or smartphones. And the beacon could pinpoint an item's location in a room, and the accuracy is high. They are supported by iOS 7 and Android 4.3 version. There is a glass issue because the current Android version running on glasses is 5.0.4, is an older version. So in order to manage beacons through glass, we have set up a temporary workaround. Beacon is discovered by the smartphone paired with the glass, and the beacon ID is sent to by the glass to the smartphone. That's it. We are currently working on a different project, still in stealth mode, with another Italian museum, where glass experience is complemented with gamification for kids. Thank you very much for your attention.